Okay, welcome back to COSC 2325. We're going to be finishing up the chapter looking at the jump and the loop instructions. So we'll look at jump, loop, look at some loop examples and nested loops. Look at how we add and accumulate integers in an array using a loop, and then how to copy one string to another string. Okay, so the jump instruction is what we call an unconditional jump, which means that it doesn't jump on a condition. Like it doesn't jump if something's true or false. It just jumps at that when it gets to that line. So it's unconditional. So we have the syntax is JMP and the target. The target's going to be a label. So for example, here we're jumping to the label top. So it jumps to here. And this creates a infinite loop unless you have something to make that loop stop inside and get out of it. So right now, something like this would just loop forever. So the loop instruction creates a counting loop. And this is the loop that we're going to be using. It's loop and then target. So it looks just like the jump loop. The target is a label that you create. It uses this ECX register to count. So we actually set the ECX register to the number of times we want that loop to iterate. So if you want a loop to iterate from 1 to 10 and iterate 10 times, then you set ECX to 10 by just moving 10 into ECX. And that loop is going to keep iterating until ECX gets to 0. So it counts down. So if you set it to 10, it counts down to 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. When ECX is 0, then we stop the loop. And the counting and decreasing happens automatically. We don't have to do that. All we have to do is set the counter, tell it how many times we want to iterate. The assembler calculates the distance in bytes between the offset of the following instruction and the offset of the target label. So this is called a relative offset. The relative offset is added to the instruction pointer. So it's going to have, and it's going to be able to know if we look back, like if this was a loop here instead of a jump, it would know the offset of where of the instruction that it needs to go to, and then how many bytes are in that block that we're jumping to. So here's an example. Get this out of the way here. This is an example of adding the integers 5, 4, 3, 2, 1. So we move 0 to AX. AX is going to be our accumulator. 5 is moved to ECX. ECX is our counter. So this loop is going to iterate 5 times. And the first time when we go into the loop, let's see here. So when we go into this loop, we add CX to AX. So it actually adds the 5 to AX. So 5 plus 0 is 5. And then when it gets to loop L1, it decreases ECX to 4. 4 is not equal to 0, so it loops again, and it adds 4 to AX, so that's 5 plus 4. Then ECX gets decreased to 3. 3 now gets added to, 3 gets checked to see if it's equal to 0, and it's not. So then we add the 3 to the 9. So 3 plus 9, 10 is 12. And then when we get here, ECX gets decreased, and now ECX is 2. We go down. 2 is not equal to 0. So now we add the 2 to our accumulator. So now we've added 4 plus 9 plus 3 plus 2 is 14. And then our ECX gets decreased one more time to 1. 1 is not equal to 0. So we add the 1 to our total, and then, which is 16, and then, right, 2, 4, 5, 10, 14 is 15. And then we decrease ECX to 0, which is ECX is our counter. 0 is equal to 0, so we stop the loop. The loop stops. So the loop stops when ECX gets to 0. When the loop is assembled, the current location, this location right here, offset of the next instruction, -5, is added to the current location, causing a jump to location 9. So the offset is added so that we can then go to this location. So we have location E, offset of the next instruction is added to the current location. So we subtract 5, causing it to jump back up here. Okay, so it says, if the relative offset is encoded in a single signed byte, what is the largest possible backward jump and what is the largest possible forward jump? So this is in bytes. So this is the largest possible backwards jump is -128. And the largest possible forward jump is 127 bytes. Because it's in a single signed byte, and this is the range of a byte. So if we try to jump more than 127 bytes forward, then it gives us an error. It will tell us and it'll tell us how many bytes we're trying to jump, like how many extra bytes we're trying to jump. So here we're looking at an example of a loop, and we want to see what's going to be the final value of AX. So you could pause this and just do it on paper. So our counter is 4. That means that this loop is going to iterate 4 times. ECX is 4. AX starts at 6. So the first time we increment to 6, we increment AX to 7, then 8, then 9, then 10. So it'll be 10 because this loop iterates 4 times. And you can type this into Visual Studio. You can look at AX and you can look at ECX, and you can see how ECX gets decreased every time the loop iterates, and you can see how AX gets increased those 4 times. So you can see the totals. And then it says, how many times will the loop execute? So it just wants to know how many times the loop is going to iterate, go round and round. So here we're moving 0 to ECX. So remember, we go into this, we increase AX, then here we check, before it checks to see if it's equal to 0 or not, it decreases. So the first step is it goes inside and it does this. It decreases ECX to -1. And then it says, is -1 not equal to 0? That's true. So it goes through the loop again. And it's going to be -2, -3. So it's going to be an infinite loop. And it actually stops at like 4 billion something. So it will eventually stop, but it will execute over 4 billion times. So final value is 10. And this will stop at 4,295,967,296. That's how many times it will loop. Okay, nested loops. So if you need to code a loop within a loop, you have to save the outer loop counter's ECX value. So let me get a pencil here to write with. All right, so we're going to start here where it says move. We're moving 100 to ECX. So right now, ECX has 100. Now we have to move. Okay, so now we're going in here. And what they're doing is they're saving this outer loop counter into count. So count also contains the 100. I'm just going to say C for count, so I don't have to, because this is so slow for me to write. Trying to do it with my mouth, the pad, the mouse pad. So we save the counter, and now we move 20 into ECX. This counter 20 is going to be the counter of the inner loop. This is the inner loop right here. So this goes away, and this is 20. But we have to save this so that we know how many times to do the outer loop. So what's going to happen here is the outer loop will execute 100 times. And for each time that the outer loop iterates, the inner loop will happen 20 times. So when the outer loop is 1, the inner loop will do 20 iterations. Outer loop becomes a 2, 20 iterations. Originally, we're counting backwards, so 199. I'm going to count forward 20 times. When the outer loop is the third time that it iterates, inner 20. So if the question is how many total times does the inner loop iterate? It's 20 times 100. That's how many total times that inner loop iterates. So it's 2,000 times that inner loop iterates. The outer loop only iterates 100 times. Okay, and we're going to look at this on Visual Studio in a minute, how the iterations happen. So this here goes 20 times, and once it's done, once it goes 20, 19, 19, all the way to 0, it goes to this statement, and now count gets moved to ECX. Remember, count was 100. So now this loop is going to right here, we're going to decrease count to 99 and compare. So it becomes a 99. And then we say, okay, is 99 not equal to 0? That's true. So it goes back up here. And we're iterating loop 1. So we're going to move ECX to count. Sorry, count was moved to ECX. Just so this was 100. And I did the wrong thing. ECX is the one that gets decreased to 99. This is still 100. Okay, so I just messed that up. Let me just start over on this. So when we go in here, we move count to ECX. Count is 100. We move it to ECX because it had a 20, so it became 100. Then it decreased it to 99. Then it checks, is 99 not equal to 0? True. So let's go here. ECX gets moved to count. So now ECX becomes 99. And then the 20 gets moved to ECX. So this becomes 20 again. The inner loop gets iterated 20 times. 1, 2, 3, 4, 7, 9, 10, all the way 20. We get out. Count gets moved to ECX. And we keep going and going and going until outer finishes. Outer has to iterate 100 times. Okay. So the following code calculates the sum of an array of 16-bit integers. So these integers are right here, 100, 200, 300, 400. They're in an int array. They're 2 bytes each, 16 bits. We offset int array. So we take the address of int array and we put it into EDI. So EDI has the address of where word lives. Get the pen again. Okay. So EDI points to int array. ECX has the length of int array. So the length of int array is 1, 2, 3, 4. It's how many elements are in the array. So ECX has a 4. And then we just clear out the AX register because it's going to be our accumulator. Then here we take EDI. So remember, EDI points to int array. EDI with nothing, just EDI by itself is going to give us the first number and it's going to add it to AX. So AX now has 100. Then we say type int array. Type gives you the number of bytes of int array. So type is 2. Boom. You add 2 bytes to EDI. So now what that does is it moves the pointer to here. So now EDI points to this address because you've added 2 bytes to the address. And we go here and we add 200 to AX. And every time that we loop, remember ECX is decreasing. And ECX was set to 4. So this is going to iterate 4 times. We're going to do this 4 times. So it's going to add 0 to 200 to 300 to 4,000 H. And it stops when ECX equals 0. So this would be a good example to enter and test out. I have a different example here that I'm going to show you. I can get out of this. There we go. So first, I'm going to show you this embedded loop. So we have 2 loops. And then I'll just show you the kind of like the example that we just did a second ago where we added an array of integers. So you can see both of those. Move a few things out of the way. Okay, so this right here, I actually copied from your book. This example is in your book, or you can just type it in. And it has some new mnemonics called push and pop, which I'll explain. But first, let's just take a look and see what this looks like. So I'm going to run it. And what I want to look at over here, lots of things in the way. I want to look at my registers. So I just want to look at EAX and ECX. So ECX is my counter. EAX is going to just move some things and it looks like it's going to accumulate something. So I'm going to step over. EAX gets cleared out. So EAX is going to be my accumulator. Now I'm going to set my counter to 10. This is how many times I want my outer loop to iterate. So ECX gets set to 10. Now, this right here, this push ECX, what this does is this puts the value of ECX on the stack. It like saves it for us. And so this is another way of, remember earlier we saved the counter into a variable called counter. We said move ECX to counter. So we were saving that value. This does the same thing. This saves the counter for us, just saves it on the stack. So ECX will get put on the stack and we can get it back by saying pop. Pop will put it back into ECX. So here we're saving our counter. We move 3 to EAX. So let me step over those. Save the counter, move 3 into EAX. Here's EAX, it has a 3. And now we're going to go into the inner loop. So we move 5. We add 5 to EAX. So EAX has a 3. Now it has an 8. And we're going to keep looping. Now notice when we loop, so right now ECX is a 5. Notice when I click step over, ECX is going to decrease to 4. And it goes back up to L2. And it did a check there. It checked to see if 4 wasn't equal to 0, which is true. So that's why it loops it back up. And then we're going to add 5 to EAX. So this 5, this 8 is going to be 13. And there's 13 in hexadecimal. And now our 4 is going to decrease to 3. And then we add 5, which is 12, decrease to 2, add 5, 17, decrease to 2, add 5, and decrease to 0, and we stop. And the value when you exit this inner loop, the value is 1C, which is a hexadecimal for 28. And then we pop EC. What pop does again is it goes to the stack. It grabs that number that we put there. The number that we have put there was this 10. And it takes that 10 that we pushed on the stack and it puts it back into the register. So now ECX will have a 10. So it gets reset to 10 up there. And so the outer loop is going to go 10 times, and the inner loop is going to, for all those 10 times, the inner loop will iterate 50 times. The thing is that, so 10 times 5 is a total of 50 times that we iterate. But we're not accumulating the inner values in this case, because in this case, they're doing a move right here. This move erases that 28 and it starts over with 3. And it starts over with 3 and then it adds 25 plus, this is 25. 5, 10, 15, 20, 25, and it adds the 328. It goes back up and it erases that 28 and starts with a 3 again. 5, 10, 15, 20. All it. So this inner part here is gonna just keep giving us 25 and adding it to that 3 there. So, but I'm just gonna keep clicking on it. Notice where we're out down here. So look at this yellow um, arrow, and I'm going to keep stepping through it. Go to the top, go in the loop. Now we're going to go 5 times in the loop. Now we exit, we go back up to the top. And keep doing this. And this will happen 10 times. Okay. And it's going to end up with a 28 just because we're clearing the register here and starting over with a 3. Now, if we were to take this out, stop this. If we were to comment this line out, then this would be 25 and it would do it 10 times. So it would do 25 times 10. So the total value would be 250 in hexadecimal, whatever that is in hexadecimal. And so the other thing that I do want you to try out also, so I want you to try this out and then try out the array. So they had an array and they stepped through the array and they added the values of the array. So they had some kind of array. I'm gonna go ahead and call it array, not a variable. And it's word size. And then they moved into EDI the offset of the array. My array is called array 1. And then into the counter, they moved the length of int array, length of int array. Mine's called array 1. And then they have some accumulator and they set it to 0. And this accumulator is going to hold, it's going to add these. And we're using the AX register because this is word size. If this was D word, we could use the EAX register for accumulator. Okay, and then they did a loop and the label they created was L1. Remember, this can be anything you want to create, just that it follows the convention and rules for creating, not the convention, but the rules for creating your labels. So L1, and then we have add, and then we're adding into AX the first value of ECI, and then we're going to move or add, oh, then we're going to add it to EDI the next byte, the next 2 bytes. So here you could say 2 because we know that it's 2 bytes, but if you didn't know, or if you thought maybe at some point the array could get changed to a different size, then type would be the best thing to do. So it's the type of our array, which is array 1. So this will give you a 2 also. So this adds 2 bytes to the offset that's been saved into the EDI, which is the address of where array 1 lives. Okay, that's it. So we're going to look at EDI register, AX, we'll look at ECX to make sure that it was set to 4 and then it decreases every time. So let's set a breakpoint here. First instruction. All right. Step through it once. EDI gets the offset of array 1. So here's EDI. Here is the offset of array 1. And we can look at the offset by going to the memory window. And we can type address, the and sign, and then the name of our array 1. And this gives us the address of where it starts. See, it starts at FC 4000. It also shows us the values. So here, these are byte size. If you right click into the window and choose 2 byte integers, then it'll show you the array. The first element contains 100, hexadecimal, 200, 300, 400. So you can see those values also. But really what we want to see is the address. That's the same address that we put into the EDI register. Okay, so then AX gets cleared out. Well, not yet. ECX gets the length of array 1. So ECX gets set to 4. This is the length of the array. 1, 2, 3, 4 has 4. The length is 4. AX got cleared to 0. This is AX. AX starts here after the 3. You could clear it out. You could clear out all of EAX if you wanted. And then here, the first element of the array, so this grabs ECI with the brackets here. You don't have to have the brackets, by the way, they're optional, but it grabs this 100 because this points to the 100. ECI has the address that points to the 100. See right here? This is the address of the first element. Okay, go back to the register. So we're going to add that to AX. So step. So now AX has that value. And then in hexadecimal. And now we're going to type array. So type array would be 2 bytes. We're going to add 2 bytes to EDI to get the next. So EDI now has 4002 and it gets the next number. And we're going to do this 4 times. So now notice over here, ECX is 1. And ECX got changed to 0. 0 is not 0 is equal to 0. That's true. So it will exit. Because 0 is not, when it says it's 0, yeah, it checks to see if counter is equal to 0 right here. And if it's true, it exits. So then we get the total. And so we've added 100 plus 200 plus 300 plus 400. And this is the value that it gave us. So we have 2, 3, 4, 5, 6, 10,000 in hex. right? So let's find out what is 10,000 in 10,000 hex in decimal. So 10,000 hex would be, okay, so the number that it gave us was, so we're just checking this number right here. We're checking 1B A4 to see what that total is. I did not add it correctly. Let's see. For some reason, 0 got moved to AX. Oh, okay, well, for some reason, I'm not getting the right value here. I'm going to change these to 1 byte. I just want to see what it comes out to. Stop it. Oh, I need to add a break. Yeah. Okay, well, I'll take a look at that. But in any case, this will go through and take these values and add them together. Or maybe I'm just not converting correctly. You can try that at home. So here's asking you if you were gonna sum a double word array, what changes would you make? So let's go back and look at that. So if this was a double word array right here, we don't have to change anything with the offset. This is fine. The length of the array, we don't have to worry about that. But we would have to make this register our accumulator. We would have to make it EAX register because we're now going to be getting a double word size. Okay, this is an example of copying a string. So our source string is this. This is the source string. And it has a end of line. And then here, target. We have to make the target the same size as our source. So they use size of source. So this gives you how many characters total, including the null character. How many total characters are in this byte? And so we make a target that is as big as this source. They move 0 into ESI, which is our index register. They get the size of source, move it to ECX, so this is going to be a loop counter. So it's going to loop through each character. So whatever this size is, let's say it's 20, 30, whatever characters are here, that's going to be the ECX counter. Then it's going to take source, ESI, so get the character from source, and move that into AL. There we go. So ESI 0 first. So source 0 is the T. Then we move the AL into target sub 0. So the first byte in target. Then we increase ESI by 1. And the reason we're increasing ESI by 1 is because these are bytes. If this was a word size, then we'd have to increase it by 2. Then we loop back up to the top, and we're at the next letter. So we take that next letter, the H, this gives us the H, and it moves it to the AL. This takes the H, and it moves it to our target array, string array. Then we increase ESI to 2. We were at 0, we went to 1. Now, yeah, we went to 1, now we're at 2. So we go here, source 2. Remember, source, this is source 0, so source 1, source 2 is the I. And we go through each letter and move it to the target array and increase ESI to move to the next character. So remember here, ESI is 0. So what we're doing is just adding 0 and then 1, 2, 3, and then we're taking that number, and it's a way to get to each character in our array. So this should remind you of what you did in C++ or Java, where you have array name, and then you have here a variable that goes from 0 to total number of array. So here says, rewrite the program shown in the previous slide using indirect addressing rather than indexed addressing. So this is what we call index addressing. And then indirect addressing, if you remember, it's using offset. So this is indirect addressing. So it says use offset instead of using indexes. I prefer indexes just because it reminds me of the high level language. But either way, it's pretty easy. Okay, so we are not covering the 64-bit programming section. This is where we're going to stop. I added to your Canvas shell the end of chapter review answers for chapters 1 through 4. It's going to be, it's a review for your exam. Your midterm exam is after this chapter. So you want to start preparing for that midterm exam by doing all the end of chapter reviews. There's one, I think chapter 2, you don't have to do the end of chapter review. You just have to study the quiz for chapter 2 and the programs that you wrote. I think you wrote programs for chapter 2, whatever assignment you have for chapter 2. So, so for the exam, you want to study all the end of chapter questions that I gave you there. I gave you the answers. And then you want to study the programs that you've written and study all the examples in your book. So all the coding examples, look at those and make sure that you understand them. If you don't, then run them on Visual Studio. Okay? And then, of course, email me if you have any questions. All right, guys. I hope you enjoyed chapter 4 and don't forget to practice. Thank you.